All right, standard 2 is about multiplying radicals. And the thing is, in order to be able to multiply radicals, you first need to make sure that the index is the same. So there is a rule that says the nth root of A times the nth root of B. So in other words, the index must be the same. If the index is the same, then I can go ahead and combine by multiplication the A and the B underneath the same root sign. So the nth root of A times the nth root of B would be the nth root of the quantity A times B. So for this first problem right here, let me go through and fix the focus. Okay, for this first problem, it has an index of 2 and an index of 2, so the same index, which means I'm allowed to go through and say the square root of 5 times the square root of 3 is the square root of the quantity 5 times 3. And I'm not going to be able to make a group of 2 out of this. So then when I simplify that, I simply will have the square root of 15. For number 2, this does mean 4 times the square root of 5 times 3 times the square root of 3, right? And when I have, let's say, A times B times C, that is the same as B times C times A or A times C times B, right? We can change the order up. So this, which is a coefficient or a number outside of the radical sign, and this, which is outside the radical sign, I'm just going to rearrange them because of this rule like that, and then I'll have the square root of 5 times the square root of 3. However, the square root of 5 and the square root of 3, they have the same index, right? They have an index of 2. So I can do 4 times 3, which is 12, and then I can combine under the same root sign 5 times 3. I'm not going to get a pair, so then I'll just be left with this 12 times the square root of 15. Okay, on number 3, I have a 2 right here. I have a positive 1, so 2 times 1 is just 2. And then this has index of 2, so I'm able to combine those under the same radical sign. Just going to change the order up a little bit, put the numbers together and then the variable. So 15 times 12, and then I have x cubed times x to the 4th. Okay, and then I'm going to go ahead and break this down. I mean, I could say 15 times 12, but I'll get a bigger number. So instead of making the number bigger and then breaking it down, I'll just break it down from right now. So 15 is 5 times 3, and 12 is 4 times 3, and then x cubed and x. So wherever I have a group of 2 or a perfect square, I can remove that from the radical sign. So I have a group of 2 for the 3's. So now when I bring it out, it's going to be to multiply just like before. 2 times 3. I have the square root of 4, which is a perfect square. So I'm going to say that's times 2. Okay, so I took care of that, that, and that. Then I have not only one group of x, but a second group of x. Okay, I've taken care of everything inside with the exception of this, the square root of 5. So then when I simplify this, I'm going to have 2 times 3, which is 6, times 2, which is 12, times x, which is x squared. So 12x squared, and then the square root of 5. For number 4, I'm going to have negative 5 times the square root of 3r times negative 1 times the square root of 2r cubed. So I have negative 5 times negative 1, which is positive 5. Index of 2, I just made them all square roots, I believe. So then I'm going to rearrange while I write these down. So I'm going to have 3 times 2, and I'm going to have r times r cubed. 1, 1, and then 1, 2, 3. Okay. Okay, well, I'm not going to get a group of 2 out of this, so that's going to be 5, and under the square root sign, I'm still going to have that, but I'm going to put it back together and make a 6. And then I have one group of r, and I have another group of r. So when I simplify that, I get 5r squared times the square root of 6. Okay, on these are a little bit trickier, I suppose, but it's really just the distributive property. I'm going to take this whole amount and I'm going to multiply it times the 3, right? So let me off on the side. If I had 2x and then I had, 3 minus 4x, and I distributed, I would say 2x times 3. And then this is a positive 2x, so plus 2x times negative 4x. And then I would have 6x plus 2 times negative 4, x times x. And these are not like terms, so I would be completely done at that point. I cannot combine these coefficients, the 6 and the negative 8, together because this is x to the first and this is x squared. Okay, so if I had 5 times the square root of 6 times 3, I'm going to have 5 times 5 square root of 6 times 3. This 5 is positive, so plus 5 times, there's a negative 1 right there, so I'm going to say negative 1 square root of 6 times the square root of 6. So 5 times 3 is 15, square root of 6. The square root of 6 is just 2 times 3, so I'm not going to be able to find any groups of 2 down there. 5 times negative 1, that's going to be negative 5. And then I'm allowed to, they have the same index, so I'm allowed to combine them underneath the same radical sign. So 15 square root of 6 minus 5, I have 2 of them, so I can bring one out. So 15 square root of 6 minus 30. Now, this does not, oh no, it froze. Hold on. Let me close it and open it back up. That's only a lot annoying. Okay, so what I started saying was that this does not have the square root of 6 on it. And since it does not have the square root of 6 on it, these are not like terms. Okay, we only can combine like terms when it is the same base raised to the same exponent. Well, a little bit of a sidebar. When we have the square root of something, when we have, let me make it a little bit more basic, when we have the nth root of a base, that can be rewritten as the base to the exponent 1 over n, whatever the index is. So 15 times the square root of 6 can be rewritten as 15 times the base to the 1 over n. Well, n is 2, so I would raise that to the 1/2 minus 30. I can only combine like terms when the base and the variable are exactly the same. Here, there is not an additional base. This is not being multiplied by something. Okay? So I cannot combine the 15 with the 30 because this has 6 to the 1/2. This does not. They are not like terms. Therefore, that is why we stop right here. Okay, on this one over here, I'm going to take 3 square root of 15. I'm going to multiply it by the square root of 5. And then 3 square root of 15 is positive, so I'm going to say plus 3 square root of 15. So I did that, and now I'm doing this one, times 3. Okay, so these have the same index, so I can combine them. But instead of making the numbers bigger, I'm going to actually not multiply them, and I'm going to say that this is 3 times 5. And then this is going to come down times 5. Plus, and then over here, I'm going to have 3 times 3 times the square root of 15. Again, 15 is 3 times 5, but I'm not going to get any groups of 2 from that. Okay, over here I do get a group of 2 from the 5s, so I'm going to say 3 times 5. I took care of that, but I still have the square root of 3 on the inside. And then over here I have 3 times 3, which is 9, it's positive, times 15. The reason why it's 15 is I don't have any groups of 2 right here. So 3 times 5 is 15, square root of 3, plus 9 times the square root of 15. If I rewrote this with the base, I would say 15 times 3 to the 1/2, plus 9 times 15 to the 1/2, but they don't have the same base. In order for us to combine these coefficients, I'd have to have the same base raised to the same exponent. Same exponents, but not same base. Therefore, we don't have to combine them, and this is your final answer.